Hi there, Doug Stewin with IT Creations. Today we have a somewhat older system, but one that is still quite powerful and relevant. The HPE ProLiant XL675D Gen 10 Plus GPU server. This server is housed in the HPE Apollo 6500 chassis and is designed for the exascale era. Exascale refers to floating point operations per second, or flops, which in this case is A1 followed by 18 zeros. That said, the actual phrasing they used is exascale era, so take from that what you will. Purpose-built to support either NVIDIA NVLink technology or AMD's Infinity Fabric, it can be outfitted with a number of GPU options, either XXM4 or PCI form factors. Let's take a look at this 6U beast. This system can tackle AI, machine learning, deep learning, and other highly complex, high-performance computing tasks with ease. This is a configure-to-order system. There are three main parts to this system: the Apollo 6500 chassis, the dual-socket HPE ProLiant XL675D Gen 10 Plus compute node, and the GPU tray. The Apollo 6500 chassis can also be configured with two single-socket HPE ProLiant XL645D Gen 10 Plus server nodes with a single AMD EPYC 7H12 64-core CPU, or just the single XL675D Gen 10 Plus we have here. This XL675D can support either 8 NVIDIA HGX A100 80GB GPUs or AMD Instinct GPUs with 8 to 10 double-wide or 16 single-wide GPUs, whereas the XL645D offers a single socket and supports either 4 NVIDIA HGX A100 40GB GPUs or AMD Instinct PCI options with either 4 double-wide GPUs or 8 single-wide GPUs connected via AMD Infinity Fabric. Potentially, you can install 8 2.5-inch SAS, SATA, or NVMe drives in each of the two drive cages for up to 16 drives total. Drive box 1 on the left and drive box 2 on the right. If this was configured for the XL645D half-width node, then those two drive boxes would be divided between node 1 and node 2 respectively. The control panel for each of the server nodes is useful when you have two nodes. In this case, we just have the one HPE ProLiant XL675D Gen 10 Plus node. Each of the control panels has a power on button with integrated LED, health LED, NIC status LED, and unit ID button LED. With our current setup, with the full-width XL675D server node, only the right control panel is active. Once you remove a few screws on top, pressing the large button in the center allows the front panel to tilt down, exposing the drive backplane, expansion boards, and a bank of 15 hot swap fans with redundancy. Are you interested in the HPE ProLiant XL675D Gen 10 Plus server, supported by the 6500 Apollo chip? Back of the system, that upper portion has the GPU tray, which depending on your needs can be either NVIDIA or AMD PCI-based GPUs or SXM4 GPUs. In this case, we have NVIDIA HGX A100 SXM4 GPUs with 80 gigabytes of memory each, connected by NVIDIA's NVLink technology. There are 8 of them behind a simple perforated metal panel for airflow. While this system does come built to order, given the list of approved customer repairs, it does appear that you can switch out the GPU tray for something else if need be at a later date. Other GPU trays can be purchased, offering either 8 to 10 double-wide PCI cards or 16 single-wide cards. The PCI GPU tray definitely has a different look with all of the PCI slots in back. If you were to order the half-width XL645D, there would be 2 separate GPU trays, each with either 4 NVIDIA HGX A100 SXM4 GPUs, 4 double-wide GPUs, or up to 8 single-width GPUs from AMD's Instinct Performance HPC AI GPU lineup. That would be per GPU tray. Once you release the thumb screws on the levers, you can use the levers to pull out the GPU trays. In this case, singular GPU tray. The compute trays are secured in a similar fashion with thumb screws holding the release levers in place. A bank of 6 power supply units are just below the GPU tray, offering 4+2 redundancy. Beside that, an APM 2.0 connector, short for the Apollo Platform Manager 2.0. The APM allows administrators to manage HPE Apollo and Moonshot shared rack infrastructures. The actual system like this XL675D or the XL645D and rack level power settings from a single user interface. Integrated lights out, or ILO, is embedded on the system board of the XL675D and also compute node. Starting on the left, a 1 gigabit Ethernet port with dual USB 3.1 Gen 1 connectors, a video connector, and optional serial port. There's also an OCP 3.0 card slot right in the middle of the chassis, which in this case is used for a pass-through module. Using the levers to pull the compute module out of the XL650 chassis, you can see the 2 release levers on the top of the unit. Once you engage the release levers, the case separates like a clamshell with PCI switchboard on top and the CPU memory tray on the bottom. The PCI switchboard has 5 PCI switches, plus SAS and NVMe slim SAS connectors for drive support. The top is also where the risers plug in for NICs and HD controllers. For network controllers, there is a choice of high-speed Ethernet, InfiniBand, or HPE Slingshot. The Slingshot option is a one-use switch that offers a high-bandwidth, low-latency solution to optimize performance on converged infrastructures for HPC, machine learning, and analytics applications, and can scale to your needs. The lower portion of the clamshell supports the memory module slots and CPUs, plus 4 NVMe slim SAS connectors, each with a x8 connector width for supporting 2 NVMe drives each. The compute unit and the GPU tray are connected to each other through the mid-plane assembly in the chassis just behind that bank of 15 fans. This double-wide unit has 4x16 PCI 4.0 low-profile slots for the primary and secondary risers, and 2x16 full-height half-length PCI 4.0 slots in those tertiary riser. Those 4x16 low-profile slots can be used to support a balanced I/O fabric, while the other slots in the tertiary riser can be used for HPE smart controllers or that boot device if you want to preserve all of your upfront storage. There is also a place on the system board for a modular HPE smart controller like we have on this system, which has 2 slim SAS connectors for 4 drives each. An OS boot device can be installed in one of the tertiary PCI riser slots and offers dual 480GB NVMe M.2 drives. Each of the slots in the tertiary riser are PCI 4.0 by 16 with a x8 connector link width. The boot device utilizes a PCI 3.0 interface and requires no graphic user interface or setup, automatically creating a hardware RAID 1 configuration for mirroring the 2 drives. The configuration for the front 2.5-inch drive bays is also dependent on the installed controllers, with the embedded controller capable of supporting up to 8 SATA drives or 7 4x NVMe drives. For support of NVMe drives, you will need the NVMe U.3 backplane. The other configurations with SAS or SATA use the standard backplane option like we have on this system. HPE Smart Array controllers, either a E208i-A or the P408i-A, will support up to 8 SAS or SATA drives in a hardware RAID. For the 8+8 bay configuration with SATA and SAS drives, there's the P816i-A controller, but only that last option will take up both of the front drive cages and is more for the single server node option than for the dual node server configuration. Direct liquid cooling is an option on this system, promising increased efficiency and power density. In fact, GPUs with a TDP of up to 500 watts are supported, along with CPUs of up to 280 watts TDP, so effective cooling is a necessity. There are other options for GPUs from NVIDIA, AMD, and others which are not necessarily mentioned. In its current configuration, the XL675D is outfitted with 2 3rd-gen AMD EPYC 75F3 CPUs with 32 cores each, 1 TB of memory, and 8 NVIDIA HGX A100 80GB SXM4 GPUs. Pre-configured CPU options for this model are the AMD EPYC 7H12 with 64 cores per socket, or the AMD EPYC 7532 32-core CPU. Although that said, it can support a number of other options from both the 2nd generation Rome and 3rd generation Milan series. The NVIDIA HGX A100 80GB GPUs feature tensor cores and can be partitioned into 7 separate GPU instances, and features a memory bandwidth of over 2 terabytes per second. At full capacity, it can support up to 4 terabytes of memory using registered 128GB memory modules in all 32 slots. With extensive GPU support, this system can handle the most complex AI models, machine or deep learning inference scenarios, and a myriad of high-performance computing simulations. It is built to order, but there are quite a few different configurations as outlined above, depending on your workload. This system has a price tag that will make your eyes water, but for certain applications, this is what you want and maybe even need.